right, so I think we're good to start. Thank you so much. Thank you everyone for being around here and this time a nice day as well to do an unveiling. My name is Sergio Baltasar. I happen to have the honor to support the Cummins team that comes and recruits here, and also work on my day life as a sourcing specialist out in Cummins in Columbus, Indiana, where we're headquartered. I'd like to introduce Amanda, who helped us a lot into planning and getting the agenda, along with Stanley and of course with Sarah and everybody on the engineering side of things for the student engagement. Thank you for that support and the partnership. So Amanda, I'll leave you the floor and just the insights, and we go with the agenda.
Sounds great. Thank you.
Thank you, Sergio. My name is Amanda Madrid. I'm with the College of Engineering Office of Outreach, and we will be getting started with our agenda. So I'd like to introduce Dr. David Howdy, who is our interim dean for the College of Engineering, to get us started.
Okay, well, good morning, everyone. You can hear me okay in the back? It is truly a pleasure to welcome Cummins leadership, our faculty, staff, and students, and distinguished guests to the Cummins Engine Dedication Ceremony. I feel it is especially fitting that we gather for this dedication during Engineers Week, a nationwide celebration of the engineering profession, which was founded in 1951 by the National Society of Professional Engineers, to recognize the impact engineers that have on society and to inspire the next generation of engineers. Engineers Week reminds us that engineering is creative, collaborative, and essential to building a strong and diverse workforce for the future. In many ways, today's dedication reflects exactly what Engineers Week is meant to highlight: the connection between industry, education, and the preparation of future engineers. I would like to especially recognize Robert Rivas, Executive Director of Supplier Quality, Alonso Navarrete, Operations Manager, and Arvind Manarswamy, Director of Data Science for Cummins Engineers. With that said, please a round of applause for these individuals. Thank you for all of you for being here. And more importantly, thank you for your continued partnership with NMSU College of Engineering. Now to get to why we're here. Today we are dedicating an extraordinary piece of equipment, a Cummins diesel engine weighing approximately 4,000 pounds. What makes today meaningful is not just the size or power of this engine, it is really the opportunity it's going to be providing to our students. Cummins donated this engine to enhance laboratory instruction in our Department of Engineering Technology and Survey Engineering. And by the way, I always like to mention that our engineering technology programs are the only ones that exist in the state of New Mexico, and one of a few programs in the region dedicated to engineering technology. In our engineering technology programs, hands-on learning is central. Students learn by engaging directly with the systems, such as the engine you see here in front of you, understanding components, diagnostics, controls, and performance in a practical setting. This engine will become a living laboratory. It will allow students to connect theory with real-world applications. They will not only study how these systems work, they will see them, analyze them, and work with them. This is really workforce development in action. Cummins has been a long-standing employer of our students. Over the past 3 to 4 years, they have employed about 45 NMSU College of Engineering students through various co-op positions. This number reflects a strong and sustained commitment to developing talent. Speaking also from personal experience, co-op experiences are transformative. Students return with a real-world insight, personal growth, professional confidence, and a clear understanding of how their education translates into impact on society. Partnerships like this create a direct pathway from the classroom to industry. I'm also proud to say that Cummins has been a strong supporter of our student organizations. including the SAE Mini Baja, the Society of Hispanic Professional Engineers, and the American Society of Mechanical Engineers. These organizations give students opportunities to lead, compete, design, and collaborate. They complement classroom instruction and prepare students for industry expectations. At this point, I'd like to also mention that Cummins is really, looking at the full range of opportunities for our students. It starts with a classroom experience such as this, hands-on learning, co-op experiences, student organizations, all of which we're always telling students to get experience with so they can put on their resume, and it makes a big impact on getting hired. As a land-grant institution, New Mexico State University was founded to serve the people and industries of our state. That mission remains central to who we are. We're here to provide practical, accessible education and to strengthen New Mexico's workforce. When a company like Cummins partners with us in this way, it directly supports that mission. This engine will help prepare students who will go on to work in various areas such as manufacturing, transportation, energy systems, and other industries which are critical to our regional economy. Access to equipment like this also ensures our students are competitive anywhere in the country. Now, as I'm getting close to finalizing my remarks, I'd like to recognize Dr. Sama Ben Ayed, Professor of Mechanical Engineering Technology and Interim Associate Department Head in Engineering Technology and Survey Engineering. Her leadership and commitment of our ETSE faculty ensure that this engine will be fully integrated into the laboratory instruction and student learning for years to come. To our colleagues at Cummins, thank you for your generosity, your trust, and your investment in our students. This partnership reflects a shared commitment to excellence, innovation, and the preparation of the next generation of engineers. On behalf of the NMSU College of Engineering, we are proud to dedicate this engine and look forward to continuing our collaboration. Thank you, and as always, go Aggies.
Thank you, Dean Hadigi. At this time, I would like to introduce Dr. Sama Ben Ayed for her remarks.
Good morning, everybody. It has to be up. Is that better? Yes. All right. Is that better? Yes, all right. Thank you. So, good morning, everybody. Thank you, everybody, for being here. Thank you, Dean Hergy, for the introduction. I'd like to start with a thank you to the leadership team of Cummins for their generosity, for working with us on making this happen. Sorry. On making this happen. I also wanted to thank everybody on the NMSU team who all right. Thank you. I also wanted to thank everybody on the NMSU team that made this happen. I want to thank Dr. Gabe Garcia, Associate, I'm sorry. I thank Dr. Gabe Garcia, Assistant Dean for Academics and Experiential Learning, for his support. I want to thank Professor Barbara Gamillo, Interim Department Head of Engineering Technology and Surveying Engineering. And I also want to thank Professor Luke Nogales, Mechanical Engineering Technology Coordinator, for their support in making this happen. I also want to thank the Office of Outreach for organizing this event. Thank you very much, guys, for working with us. So, a little bit of a background. We are Engineering Technology and Surveying Engineering, as Dean Harrigy was saying. We are a hands-on program. We are an engineering program that hands-on for us is really important because most of our core courses do have a lot of components. So we want to make sure that always our labs are up to date, are to the standards of industry. We're always trying to make them updated and trying to make the students have that experience so they're ready for the workforce. Cummins is not new to us. This is not the first donation they give to our program. It happened previously about in 2018 where they donated some funds to our program to fund some our thermodynamics and heat transfer equipment, and we wanted to take that to the next level. As a partner, we're like, we want something a little fancier. So we've been working on this engine donation since about 2018, before COVID. We asked them to provide an engine that's used. We didn't ask for something brand new. We're like, it's fine, you don't need it. Probably our students would need it, and it still would be of an added value. There was some quiet back and forth here and there. Tried to make it work, and then COVID hit, and then it didn't happen. But sometime like in late 2024, I got this email from Alonso Navarrete saying that we're building a new engine for you. And we got so excited about that. So by the way, we want to thank him for all the effort, and he really made this happen. So the engine landed on campus last summer, and we wanted to make it operating. So we were thinking we want to maximize the experience of the students working with the engine. So we had the idea of proposing a capstone project that would make the engine ready. With ready, I mean instrument the engine and protect it. You could see it's too nice to be left in the outside, it's too big to be in the inside, and so we wanted something to protect it, and we wanted also to instrument it, make it accessible to our students. And so the team of students here, they're going to present their work in a little bit. How do we use this engine? First, we're going to be using this in our thermodynamics lab. It's going to stuff at least 2 of our thermodynamics lab. I was also in contact with mechanical engineering department, and they are very happy. They are very excited to integrate this into their curriculum as well, again, to maximize the exposure. Also, we are planning on making this an ongoing capstone project. Now, for now, we're just looking at, as you're going to see, basic instrumentation. How do we read temperature? How do we read pressure with a handheld device? We want to make that a little more sophisticated. We want to do that on using a control panel, a control board, and we can always make this a better experience to our students. Something we're also thinking about is, well, it has much more capabilities than just trying to contrast this with a diesel engine, reading temperature and pressure. So once we get the training, we have a scheduled training to unlock all the advanced features. We were also thinking about developing a micro-credential course that would be for students who are specifically interested in the engines industry. And so I think it would be a great idea, a first exposure to these students. It's also a nice recruiting tool. We have our STEM students from the high schoolers looking for the labs that we have. This is really a great equipment to show to our students that we have great labs, that we have up-to-date labs. Now, this donation is going to be a real win-win to both parties, both to our students and to Cummins as well. So it's not going to be a substitute for a co-op or an internship for a student who's going to go in Cummins, but this is really going to be a first step for these students to learn about the industry, to learn whether, or to know whether they're going to be interested in something like engines, or if it's something that's not of interest to them. For us, it would be also a great experiential learning experience for our students, getting them ready to the market, having them one step ahead, thanks to this donation. So again, thank you everyone for making this happen, and thank you for your attendance. I'm going to hand it over to Mr. Alonso Navarrete, the key person in making this donation happen.
Before all, we have to give an introduction. Of course, I was talking just right to the one person for full circle here for everybody and disclosure as well. Rebecca in this side also. She interviewed her. She interviewed all I think in 2010. Really eager Aggie, trying to also look for opportunities out there, and a great turnout for Cummins as well, as you can see, a great alum and then also a great employee within the company. He is now a leader. I think he's also very inspiring on our side. He's part of the founder fathers per se on the group that comes and recruit here at NMSU and at UTEP as well. So we all follow in his steps, and we continue to grow the same path in which you started putting some bricks. So with all that said, I'll give you the mic now. Thank you so much.
All right, hopefully everybody can hear me okay. Bear with me here, I am a bit of a storyteller, but I will start by first offering thanks to Dr. Sama Benayed. Without her idea, this would have never happened. Without her tenacity, this would have never happened. And without her continuously reminding me that we should be working on this would have never happened. She is correct, it did start many, many years ago. We did have some problems throughout the pandemic, and it slowed down, but luckily we were able to pick it back up. And the inception of the idea was to find a used engine that we could repurpose. And that's actually what I did. I went out and found, it was a different engine. It was a 4-cylinder, 4.5 liter engine, but it was missing a couple parts, and that's why I was able to get it for a very good price. Unfortunately, finding those parts were extremely difficult because that engine was, the main purpose of it was to go to Europe, to the European market. So then as such, I just kept working it, kept talking to more and more people, and that's what got us to where we are today. Second, I want to thank the students of the project sitting here. I've been impressed with their professionalism, their thoroughness, and their documentation, the ability for them to push me as well. I think you'll see that as a common theme. I need to be pushed quite a bit, and their creativity. I can honestly say that whenever I have a meeting with them, it just makes my day or even my week. I look forward to it. And they've honestly been very creative in taking me along for the journey. The last time we had a meeting, I think they had either a phone or a laptop that they were walking me around in. I felt like I was here. This is definitely a group that myself and others should be keeping an eye on from a recruitment standpoint. So thank you. Although they couldn't be here today, a special thanks also to Donette Howard and Rick Hudson. So Donette and her team funded this wonderful donation. They are part of the Cummins Ready team, and they realized that there was a gap. Where normally we put these training modules in tech or vocational type schools, we decided that there was an opportunity to put it into universities and expand the learning. So they were very excited to create something new, although it came with a lot of hard work, and also delayed the project some. Rick was an integral part of developing the new process, all the documentation needed, the legal documents. Who knew giving something away would be so hard? Whether it was getting the signatures from the Cummins team and all our legal, but also getting the signatures from New Mexico State, which also Dr. Benayed helped with. But after many revisions and acquiring all the needed signatures, actually we got the signatures after it arrived, so I was in a bit of hot water until we got that document signed. But it all worked out. And I do want to share a quick story, kind of to touch on what Sergio mentioned and what he and Rebecca were talking about the ripple effect. I'm sure you all have heard that, right? A droplet of pebble creates a ripple effect. A little over 15 years ago, someone took a chance and created a ripple. That person was Rebecca McIntyre, who took a chance on me like she has with many others. Since then, she, the team, and myself have been not only creating ripples, but waves here at NMSU, and hiring many, many talented students. I hope that this gift creates a ripple effect. I hope it's the fire that fuels creativity in students and ignites their passion for engineering. And yes, I had to throw in some engine terms in there, of course. I'm extremely fortunate to represent Cummins. I never would have imagined that I'd be up here doing this, so I'm very thankful. Thankful to a company dedicated to doing the right thing, and fighting for people's rights. A company with vision that pushes the boundaries of technology to deliver the right solutions while reducing our carbon footprint. I truly believe that together we will power a more prosperous world. Thank you.
At this time, I would like to introduce our College of Engineering students who have worked on the project.
Good morning. Thank you for coming. My name is Renato Cruz, and I'm an engineering student, and also my.
Hi, good morning. My name is Sai. Nice to meet you.
We're gonna talk about the shelter that we are designing. So the objective of this project is to design a shelter to house the Cummins engine and enable its operation to ensuring safety, to host NMSU lab sessions, and keeping inside a continuous renewable airflow environment, for safety of the students.
Well, first we started to design this enclosure by thinking of something small that could be on the inside of the building. But later we thought, what if we build something that could be housing a lot of students so they could perform their lab outside of wherever they are, right? So that's why we made a few changes and we made a lot of designs thinking of this idea.
Yeah, so this is why we moved to start designing this shelter that we are doing. We did several designs to get the one that we finally accomplished. And well, what is our model made of? Our model is made of square tubing, brackets and bolts to join the bars of the frame, and also flat bars to make cross bracing sections to strengthen the frame.
We also had considerations with the facilities of the university by thinking about the floor where it's going to be the engine and the enclosure. So we designed the enclosure so I say it again, so we can change it and move it wherever we need it. So we made the frame as heavier as possible so it could withstand the windstorms or it could not damage the floor. So that's what we did with the design of the enclosure.
Okay. Part of the design was to consider to the addition of two ventilation systems. One of them is a piping system to exhaust all the harmful gases to outdoors of the frame, and the second one is a exhaust fan to also exhaust all the heat to protect the students and keep them safe and comfortable inside of the shelter.
We also made a lot of changes about the size of the enclosure, and we tried to make the engine as efficient as possible. So we tried to put the engine as closer to the main entrance, so the most of the air can go on the radiator, and we could perform the lab. And also, so the hot gases that go inside of the enclosure can go to the outside of the building. Oh, sorry. We also we're gonna mount exhaust piping into the outlet of the engine, so all of the combustion gases can go outside of the enclosure, and we cannot accumulate anything inside of the enclosure that could be toxic. And we also created a liquid container, so all of the fuel, oil, coolant, if there is a leaking in the engine, that this container can contain all of that. This is for safety reasons.
Okay. We also perform simulations. Two of the most important involves how a lateral wind load can impact in a lateral side of the frame. So we consider the worst case scenario in Las Cruces. As you know, there's windstorms here. So the highest wind speed ever registered, is about 70 miles per hour. So this is the worst case scenario that we consider to do this simulation. Our lateral side of the frame it has 200 feet to the square as an area. So it means that it will be hit with this velocity with a 1,500 pounds force. So we decided to do the testing with, as I said, the worst case scenario. So we got a factor of safety, of 1.61. In this kind of shelters, a safety factor between 1.5 and 2 is considered safe. But again, this is the worst case scenario. In a normal situation, we can get a factor of safety of 7. So this is really high. The second simulation involves to see how the weight of the top could affect in these vertical bars. We have 12 vertical bars of the frame in the frame. So we put a vertical load of the tier of the weight of the top in one of these bars. So again, this is the worst case scenario. Is something that we decided to do to ensuring the testing was better. So the safety factor the safety factor here is even higher. So it is not necessary to mention it because we were good in this situation. And the frame is going to be as we say joined with brackets and walls, and it will be completed with the installation of our panels.
Well, just to finish the idea here, we are very excited about working with this engine and continuing developing new ideas for new students to come. And we are we thank very much to everyone that made this possible. And now, stopping with the technicalities, I'm gonna ask Diana to come to talk about safety.
Hi, do you hear me well? Hi, my name is Diana. So basically, I'm here to talk about the safety considerations that we think about. For the enclosure, my teammates Renato and Sai already mentioned most of it. The enclosure will have concrete anchors on the sides so it doesn't fly away with the winds like the ones that we had last week. Also, the door, it will be with enough clearance so the forklift can operate safely to move the engine. The floor and inside the enclosure, it will be labeled with warning labels, labeling hot surfaces, rotating parts, so the students know where to be careful. Also, there will be like the warning labels on the floor, so we can know where are the safe operation zones. And regarding the operation of the engine, we will be making like a lab safety. Everyone will have to have their personal protective equipment, safety glasses, long pants, closed shoes. If people with long hair, they will have to tie up their hair. Also, we will have to make like a previous inspection before operating the engine, so make sure everything is correct. And also, after it runs for a while, we will have to let it cool a little bit before handle everything. I think that's most of everything that we consider. Also, like my teammates mentioned, there will be ventilating systems, the piping system that will get the combustion gases out of the enclosure, and also the fan that we will get the heat out of the enclosure. And then here, my other teammates will continue how to operate the engine. Thank you.
Thank you, Diana. Thank you, Diana. So my name is Gabriel Romero. I'm an MET. So as Dr. Harvey said, part of our major MET, I'm an MET, we need to relate theory to practice. And the main idea of the curriculum that we're we're designing right now, is to do that, to relate practice to theory. So the main idea of the curriculum, as talking with Dr. Sama Benajet, is to locate the 4 points of the diesel cycle on the diesel engine. So we're talking about the compression, that's point number 1. Point number 2 is the heat addition. Point number 3 is the expansion, and for point number 4 is exhaustion. So now my classmate Josh is going to talk about how can we locate it on the engine.
Good morning. I'm Joshua Hadagi. So to expand a little bit more on the testing of the engine, on this far side, away from you guys, unfortunately, there are the intake valves, which we have a pressure and thermocouple attached to. So the goal is for the students to use that as a point 1 for the diesel cycle. And then as you follow it along, moving to the fuel line, we have another pressure sensor and thermocouple for them to be able to read. That'll be point 2. Now, the big thing here for students, as far as connecting theory to real world, is in theory, we're taught to use an ideal diesel cycle where entropy stays constant through these first 2 stages. But as the students measure it, they will see that heat loss is occurred due to friction through this. And so that'll be a huge impact on the real world testing that they'll be able to do. On this far side, close to you guys, we have thermocouples attached to each of the pistons. They'll be able to use that for a reading for point 3 on the diesel cycle. We are still working to solve for point 4. Just that way they can fully design the diesel cycle and be able to plot that and present that as findings. Thank you.
So now we wanted to ask Dr. Harvey if we can turn on the engine.
Letting the suspense build here.
So talking into the microphone, what I was able to do is I was able to get recordings for the piston on this front side, and all the data is stored on here digitally. So students can then upload this to their computers, so no data is lost throughout the test. So as long as everything's connected and you're communicating, RPM staying consistent, you're at steady state conditions, all the data will be presentable to be able to plot that full TS diagram, as well as your PV diagrams using the report the readings on the pressure sensor in the front.
Thank you.
Thank you so much.
All right, with we're close to or being in the way of having a little bit of good food out there for you from Chachi's. And next, and to wrap it up as well, I'd like to introduce another very great and inspirational leader that we have here at Cummins. I could tell you that what I know, because he's a legend by now. What I know is when I started as a co-op in fuel systems, he was a plant manager at Juarez, and I didn't know his story then. And as I got into, getting involved with ERGs or little organizations within the company, I learned his story and how he went from, the line into supervising and into running the place, the Juarez side, a native to El Paso, and with a lot of great courage and innovation and enthusiasm, he has been running large operations, and now he's supporting us on being, the one of the persons responsible, of course, on making sure our products have the highest quality standards out there, so that customers can enjoy those products that power critical things. With that, I would like to introduce our executive director for quality, supply quality, Robert Rivas. To you.
All right, I'm probably gonna have to take this mic off because I don't think I can speak like this. Glad to be here. Good morning, Aggies. When I was told to come and do this, I was told that I had to make this great speech or I could sponsor food. So there is Chachi's that I sponsored. So I don't know how good my speech will be, but in all sincerity, an awesome day. I really enjoyed, how this test cell can inspire other projects and other learnings, and they're all connected, and I'm sure there'll be much more of that. But first off, I'd like to thank, all the faculty here at NMSU. Thank you for all the work you do, because it is probably one of the most important work that is done in the world is teaching future generations, because we depend on it. It's the only way we progress as a globe, as a country, is through that learning and continuous turning out great engineers. And to the students, we need you to succeed, right? Your families need you to succeed, our community needs you to succeed, our country needs you to succeed. So it's very important that you just give it your best effort and really take as much as you can from all of the learnings. These become like little rocks that you carry around that later become diamonds, all these teachings and lessons that you get throughout your life. So just education is such an important part of success. Just learn as much as you can and ask questions, get engaged, involved. I think this is a great example of that. I really, I tell you about Cummins, we've been around 107 years as a company. And I've been almost 30 years working here, and I really think it's one of the greatest companies to work for in the world. I love it. I get to interact with people from basically every part of the world. I'm responsible for like 18,000 different suppliers everywhere, and it's really awesome the work we get to do together. But I always tell people that Cummins, it doesn't belong to us, the employees that work here. It belongs to little kids that are in school today, that are going to come work here just like the way I work here because of somebody 100 years ago and 50 years ago did a great job. Our responsibility today is to do a great job so that we leave our good stewards of this company so future generations come and have a place to provide for their families and have a good future as well. So we take that work very serious. We think that this engine, it looks like a simple engine, but this engine, beyond the Dodge Ram, which is out there, it powers that, but it powers ambulances throughout the world. It powers fire trucks throughout the world. It saves lives every day. So it's a critical piece of equipment. We make gensets out of bigger engines like this that power hospitals when the power goes out and saves lives that way. So it's a very important work that is done in all industry, and it's just the way it connects. So I really hope that this gift inspires not only this generation of students, but several generations of students and serves as a catalyst for ideas and new projects. And let's test this, let's improve this, let's figure out what happens here. And I think that's the way greatness is born. Right? It serves as this small idea, it's a spark that inspires the people to do great things in the future. So I really thank all of you for being here today on behalf of Cummins. Great work, and we look forward to doing more projects together. Thank you so much.